Hey Tarun, good morning.
Hey JP.
I don't know if I don't know who else is there actually. I don't know who is E Spin Ozzy. Do you know?
No idea. I'm
Oh, I
sorry.
see David. Hi David.
Hey JP, how are you?
I am good. How are you doing?
I'm doing pretty good.
Excuse me. Do you know who is that other person on the line? Is it from your team?
No, I do not know.
Okay. So who are E Spin Ozzy? Can you identify yourself?
Oh yes, hi Jay. Sorry, I walked away from my desk. I'm from Analog Devices.
Oh, hi. Your name?
Eric Espinoza.
Eric Espinosa. Okay. Hi.
Hi, how
Yeah,
are you,
good to
Jay?
have you on the call.
Yeah, no problem. Yeah, I've been supporting Meta for 12 years from the analog devices side, and so I occasionally join some of these meetings just to kind of
Oh, I
get
see. I
updates
see.
and think how things are progressing.
I see. Okay. Sounds good. Yeah. And we also have Shane. Hi, Shane.
Hi, JP. Yeah, my name is Shane. We haven't met in person, but I met Boppy earlier this year at a conference
Uh-huh.
where he told me about some of the work that you guys are doing, and we we never kind of followed up on that. So here I am now, but we basically do some advanced packaging work ourselves.
I see.
Developing a metal substrate technology. So felt like I would sit in on this today and see what's going on.
Oh, great. Good to have you on the call, Shane. Shane, I saw your email. You asked for that layout files, right? Package. So can
Yes.
you give I'm also curious to understand your technology. Can you give maybe next week, can you give a like 10, 15 minutes overview of your technology, what you guys are doing?
Yeah, I'd be happy to. And I think you may have spoken with VJ from Silictronics.
Yeah, Vijay, I know Vijay. Yeah,
Okay, yeah, we've worked with him, and I
I
think he
see.
shared some data that came out of one of our projects with you, just on a single transmission line. But yeah, I'd be happy to speak to the technology for 10 to 15 minutes next time. Absolutely.
Sure, yeah. Great, thank you. So I'm expecting Jawad today on the call. We have an agenda that we want to go over. Some of the questions he had, Jawad. Let me ping Jawad. Give me a few minutes. I'll be back.
Jawad will join shortly, if not on the call
Okay.
already.
Okay, can you ping him?
Yeah, he will be joining shortly.
Okay.
Hey
So since
JP.
go ahead, Tarun.
Yes, I just want to let you know I have a collaboration call at like 10:30, so I'll have to duck out like a little bit earlier today. But
Sure,
yeah.
no problem. Yeah. So in today's agenda, actually, Jawad is working with the AMAT, Applied Materials, and we are trying to see if we can actually do this the Interop project in collaboration with Jawad and AMAT and the team. So he said he's going to, Bobby won't be able to join today, but we'll kind of talk through. I want to give him a status of where we are with respect to the Interop project and what help do we need, and then trying to find out what help Jawad and team can offer.
Oh, sounds great.
So I think we are meeting. Some of you may be meeting for the first time. So I don't know, but Tarun, did you meet with David? Do you know David before?
No, I haven't met anybody.
Okay, maybe let's start with you. Can you actually introduce yourself
Yeah.
and then maybe we'll go
So
around.
sure. Yeah. I'm Tarun Prakash. I'm an IC design engineer as well as like systems design engineer here at LBL, Lawrence Berkeley National Labs. So I'm helping JP and the team over there, like try and design a modular system for the bunch of wires, for the OCP.
Great, thank you.
Yeah.
So David, do you want to introduce yourself?
Sure. I'm David Rajkov, CEO of Trace Systems. We provide EDA tools and services for architecting chiplet systems. Specifically, we focus power and thermal. Those are the two difficult areas. Apart from that, right, the whole planning of dice, substrates, right, connectivity, generating the netlist, bump maps, all that stuff, all the cool stuff. Thank you.
Great, thank you, David. Hey, Jawad.
Hey guys, so we are on a phone right now, and I have with me Paul Smith and Raphael Battencourt from Applied Materials. So while we try to connect on the Zoom, we can just start the discussion.
Okay, great. We are just going around the room introducing ourselves. Do you want to introduce yourself, since many of the room may not know you?
Sure. So my name is Jawad Nasrullah. I'm one of the early members of ODSA and had done one POC along with JP before. That was a couple of years ago, and I still volunteer for CDX Workstream.
Okay, great. Thank you, Jawad. And Shane?
Yes, I'm Shane McMahon, co-founder and CEO of advanced packaging startup called Lux Semiconductors. We're a spin out of the SUNY Polytechnic Institute in Albany, New York. And we're developing technology that leverages a metal core substrate for advanced packaging, and just looking to get involved in the community. Thank you.
Great. Yeah, thank you, Shane. So Jawad, I think that you have somebody else from AMAT as well, right? Paul. Can they introduce themselves as well?
Sure. My name is Paul Smith. I'm one of the program management directors here in the Applied AI group. Background in semiconductors, just interested in understanding what's going to happen here.
Great, thank you, Paul. Anybody else in your team there? Okay.
Yeah, my name is Raphael Bettencourt. I'm here working with Jawad on projects for Applied. I worked with him in the past at Siglu.
Okay.
And
great,
my
thank you.
background is analog mixed signal. Yeah.
Excellent, thank you.
Yeah, I'll introduce myself. My name is Eric Espinoza, and I'm from Analog Devices. So ADI is investigating a new technology especially for higher current requirements. So there's a lateral power that's being used in most cases, and what we've noticed in our industry is that lateral power is reaching, its maximum of around 500 amp designs, for example, and we're talking about like, core voltages for like processors, custom ASICs, and that type of thing. So ADI is investigating a new technology, and we've actually been working on it for about 5 years. That would allow our customer base, like like the hyperscalers and the NVIDIAs and so forth, to maximize the processor power, and we're pushing the envelope to reach designs that would supply up to 1,000 amps. And so just here to learn and to see where the market is headed, and just to basically help support any need that requires, greater than 800 amps with this new technology that ADI is investigating, or analog devices, if you will.
Okay, great. Good to know you. Thanks for joining, Eric. Um, so, Eric, would you mind leaving your email address in the chat?
Yeah, no
I
problem.
might want to ping you sometime. So,
Yeah, I can post it right now. And sorry for whatever reason my login uses my email, my computer name. So that's actually my computer name.
sure,
But
no worries. May,
I'll
maybe.
I'll post my email address on the chat.
Okay, great. Thank you, Eric. Yeah, so let me introduce myself. My name is Jayaprakash Balachandran, JP. I'm with D-Matrix. So I work on packaging and system designs at D-Matrix. Prior to D-Matrix, I was at Cisco. I've been volunteering for ODSA for nearly maybe 4+ years, along with started along with Jawad. And yeah, there's a kind of bit background about me. And this particular call, we usually discuss, we are developing an interop platform at ODSA to demonstrate the BOW interoperability between two different files, Blue Cheetah and D-Matrix. So, in today's call, what Jawad has requested is we want to find out what the status of where we are with respect to interop project, how you guys can help us actually take this idea forward, right? So I'll actually kind of walk through a few slides, and you can interrupt me if you have any questions, and we can have open discussion. Jawad, does that sound good to you?
Yes, JP, that sounds good. The team here wants to understand your big objectives of POC and what progress has been made, and where do you need help?
Okay, perfect. So let's start off with that. So yeah, do you see my screen?
Yes.
Yeah, this kind of little, I did a presentation, one of the Friday meetings. I kind of revised those slides, and I'm going to talk through it, right? So, so we actually developing, as you know, ODSA has developed a BOW 5 specifications, and two vendors, Blue Cheetah Analog and D-Matrix, have developed a 5 adhering to the BOW 1.0 16 gigabit specifications. Both of them actually demonstrated the functionality of the 5 by themselves. The goal is for the ODSA as a kind of community organization. We want to actually kind of demonstrate the interoperability. This is to actually see the different vendors who adopt different, each of different files. We want to prove that BOW can interoperate, develop completely in independent way in two different technology nodes. Right. So for this effort, actually, we actually designed the package. TESOL is part of this effort, and they actually helped to develop an organic substrate, the 525 organic substrate, where I'll show you the layout, what we have. And so with the Blue Cheetah die and the D-Matrix die. Was that a question?
Yes, sorry. Did you
Sure,
say
go ahead.
you work with TSOL to do the substrate?
That is correct, yeah.
Oh, okay. I didn't know they did that.
Yeah, so Google and Meta funded that effort along with TESOL. So, and TESOL actually completed the layout.
Okay.
And then we validated the signal integrity, power integrity, and all that. It's kind of, I would say, is about 99% ready for fab out. Right. So the three open, the package design is ready, and all the analysis have been completed. And the open items are we want to fabricate the substrate, right? The what we call as a interop package, and then we want to design the bring up board for it, right? And along with that, develop a software. Right, so the three open items are really substrate fabrication, PCB design and fabrication, And then third is actually that software development that comes with it. So
So
the
Jayab, let me
yeah,
ask
go
a
ahead.
question there. Is the reason
Sure.
Meta and Google funding this it's because they want to decouple it from Azure, or is it and then have it kind of like an open connectivity, or
Oh,
it's more than that?
no, they just they funded this effort as kind of develop the chiplet effort at BOW, right? OCP and ODSA. So
Okay.
yeah, it's a more of community participation.
Right. So it's not motivated to decouple from Azure at this point. It's just more of a open platform for others, for the community to use.
That's my understanding. Yeah, so
Okay.
I'm not aware of that Azure thing, and
Okay. No, thank you, Jayab. That makes sense.
sure. And the expected outcome of this effort, what we want is two actually. The one we want to showcase this the BOW5. This is from a ODSA standpoint. So we want to showcase the interoperability, the standards developed in open domain like in ODSA, OCP, that we have a path for interoperability, and that actually spurs the adoption. That's one. The second one is actually we wanted to as a part of the Bringer platform. So we have been talking about to different people about this Bringer platform, and what we realize is we developed this as a kind of open universal Bringer platform. A lot of people can make use of it because everybody in the industry they have some sort of Bringer platform, but they have their own proprietary thing, right? Like if you talk to Cadence, Synopsys, or all this chip vendors, they have their own set of platforms, right? And we are using this OCP ODSA umbrella, and we have the same problem. We want to bring a platform, but we want to make it universal so that in future, any bring up or any test chip that we do, this platform can be used. And the advantage is over time, we'll also open sourcing the software. Over time, we'll have rich benefits of an automated platform for testing with the hardware and software, right? So these are two our essential outcome we want to get out of this. And then next, actually, I'll go through the details, what the status and where we are. I'll pass here if there are any questions. Okay. Sorry, was there a question?
No, very clear. Thank you.
Yeah, so this is actually the way the kind of shows the entire BOW platform. So first is actually 5 test chiplets, right? So we have two, as I mentioned, there are 2 test chiplets available from BCA 12 nanometer implementation, D Matrix 6 nanometer. Both are silicon proven, and then the next is actually the interrupt packaged, right? We have a 40 by 40 millimeter package and 5-5 design, and that's been done and completed in organic substrate. And so we are the fab vendor we are working with is actually ATNS. So the ATNS been very collaborative, supportive of this effort. In assembly, we have been talking to JSET, and they were also very supportive of this effort. And I think overall, the Google, Meta, and everything, and in cash and kind, they spent about like 50K to develop the substrate, right? And what we need, I mean, ATNS, they were willing to do a lot of it for ODSA, but one thing they were asking for is actually um, pay for the mask cost. So they were saying that would cost something around about 35 to 40K for the mask cost that they will have to order from externally. The rest of the services, they said they will offer it at cost. They will take care of it. So that is one cost. The other thing is actually when we're talking to JSET said they can actually do this assembly as well as substrate. Together, they were quoting something like about 95K, right? So we don't know what the ATNS cost is. Only that is only the mask cost. There's not assembly. So as a ballpark, together with the substrate cost and assembly, whatever Jason quoted, is what we actually have it here, the 95K estimate. Right. And the third part is actually bring up PCB along with the reusable software framework. And so LBL is collaborating on this. From Tarun is here on the call, Lawrence Berkeley Labs. And so they actually collaborate on a open source FPGA design for this effort. And then we have NXP is very interested in this effort. They have doing something internally where they think it's beneficial for them to actually develop this bring a platform in public domain. So and they are willing to contribute this year about 30K, and next year also they were willing to contribute in a similar amount towards this effort. And the status for the bring up PCB is in definition. We haven't started the design yet. Looking for partners. It's in definition, and the estimated cost. This is actually kind of estimated cost based on NXP and other people, is about 190K for the. I think it's something like 25 boards are in that range. Right. So and finally, we'll host this interop demo in LBL facilities. LBL will have that labs available for this effort. And okay, and the next is actually on the the bring up board feature itself, right? So I'll go into technical details of the board. Maybe first I'll show you the layer, the package itself. This is what the package, what we have, the interop package, what is done available today in the layout. It consists of 5 test structures, TS1 to TS5. And you can see here the TS1 test structure. Actually, it's actually the D matrix to D matrix. And then the TS2 is blue cheetah to D matrix long line. And then we have blue cheetah to blue cheetah long line, right? 20 millimeter. And then we also have a short line, blue cheetah to blue cheetah, and blue cheetah to D matrix. So 20 and 5 millimeters.
Can I ask another question, sir?
Sure, yeah, go ahead.
For the blue cheetah 5 millimeter that has the bend in it, are you saying that the lengths of each of the interconnects is different? It looks like they're all different. Did you play around with the lengths at all to make them match, or is that not the issue? Is that not a concern?
Oh, so between, you're talking about BCA to BCA or BCA to D matrix?
BCA to BCA.
Yeah, so actually, the one of the use cases somebody was requesting was really the 90-degree bend. Right here, if you see here, everything is straight, but we also want to demonstrate that if you well, there will be a skew in the bus if you actually do a 90-degree bend, and we want to showcase if that is still feasible or not. So it's the same interconnect, everything's same, but except that it's actually skewed. The clock bend lines have been skewed, and Google did the proof of concept layout for this, and it did work out. So we have that, we analyze this use case, and the IE, everything actually meets the requirements of the BOW spec.
Okay.
Right. So, sorry?
I just said thank you.
Oh, sure. Yeah. Yeah, and overall, we have 10 dies in the substrate, the 40 by 40 millimeter. And it's 525, 130 micron bump pitch, 1 millimeter ball pitch, and it uses GL102 dielectric, and it'll have 5 test sites with long and short interconnects. And so the overall, the speed at which run will be like 16 gigabytes. Right, so each of these test sites, you will have all the test interfaces brought out separately, the clock and everything. So it'll be controlled separately on the independently can be controlled on the bring up board. Right, so next, actually, this is the bring up board concept that we have been thinking about. So what you see here is actually a big motherboard and consists of 3 boards, right? One is actually Raspberry Pi, and then which is mainly used for control and monitoring purposes. and it can be, the board can be controlled remotely using this Raspberry Pi, and runs a standard Linux software on this Raspberry Pi. And then we have FPGA, and an FPGA board is where LBL is contributing to. An FPGA will be used to actually connect to the DUT board. And the idea is some of the interfaces have got different voltage level, 3.3, 1.2, and maybe 2.5. The FPGA will take care of this, any such voltage translations. And also it'll have its own logic. For instance, you have a JTAG. It can be handled, whatever the duty specific logic, the FPGA can handle it. And Raspberry Pi will in turn control the FPGA with a standard interface. Any DUT specific interfaces, FPGA will handle it. So thereby making it more universal. Any type of DUT with any interface can be accommodated with this solution. And then the third is actually, the board is actually a DUT part. The DUT part is actually kind of pluggable module. So today we'll design it for, let's say, for interrupt package, the DOW specific interrupt package. And the same board can be swapped with another future test chip or any company's test chip for that matter. Right? The DUT will have the temperature, thermal head, and any duty specific. It's more like a passive board with a socket, and all the intelligence is on the FPGA and the Raspberry Pi board on the motherboard. And so that way it becomes more easier to design for any future duties. Right. And then so we'll have a bunch of power modules. The power modules are again in turn pluggable as well. So the whole platform, clock, power, reset, and all these are programmable. So on the board, and it can be customized by software based on the duties characteristics. Right. So this is actually what we have, a concept we have. It looks kind of universal, but that's where we need also help in actually defining this more. We want to go with multiple partners who are already doing this, for instance, Cadence, Synopsys, or the other people who are maybe interested in this. And we want to define this as an industry platform, so more people can benefit out of this once we develop, so that you don't have to develop, every company need not have to develop this individually for their own test chips. Right, so this is the high level essential idea. And then I think I have one more slide that talks about yeah, this is a kind of high level block diagram. So the FPGA is Arctic 7, and what are the IOs it consists of? It's got a very rich IO connectivity to the DUT, and thereby making it more universal for controlling any types of DUT. Right. So yeah. So this is what we have: the 3 platform the interrupt package, and bring up board. And any help you can offer in this would be great to move this project forward.
So, JP, this is very good. So, can we go back to the slide where you have your numbers that you are looking for support?
Yeah. So, you mean this slide, right?
So, sounds like that the board and the software work is in definition phase, and that's probably going to take some time.
Correct.
But you already have made some progress on the package.
Yes, package, we made a very good progress. So we already have that design done.
Yeah. So you have the final ODB in your hand, and you have given it to AT&S, and they are saying they pay us for the mask and we'll manufacture.
Correct. Yeah. So they actually reviewed the design and have some feedback, gave us on the DFM, but we haven't gone to the fabrication part for the lack of funds.
Okay. So you have a very clear idea, how much they need to get the thing done. So they will.
Yeah. There are 2 parts to it, Jawad. One is actually that they were asking for something like 35 to 40K, which I'll forward the emails to you. and 40K for the substrate mask fabrication. The next part is actually for the assembly part. Assembly part, we are not sure because Jay said whatever that code they gave is actually includes assembly plus the substrate cost. So if you're going with the ATNS, we'll probably have to kind of unbundle the assembly part, right? We have to do assembly elsewhere.
So JSET is saying that they will take care of the substrate and assembly, right?
Correct. That's what they have given the initial cost proposal.
Okay. And do you know if they will behind the scene work with ATNS for substrate or?
Yeah, they're willing to work. We haven't talked in that
Okay.
after that. So they said if let's say if ATNS were to come forward, they said they'll be working with them. So
Okay. So you have that figured out, and do you have commitment from Blue Cheetah and D-Matrix to provide silicon?
yes, we have to actually re-establish that. This is probably 6 months, something like this. But we can actually go back and revisit it. And Bobby is here. We can actually reinitiate that thread again that we want to move forward with this project.
I see. Okay, so that part is pretty clear. Tell me a little bit more about the bring up PCB and the estimates that you have, and do you need help in making the boards? Do you need help in writing software for it?
No, that'll be great. Yeah. So, I mean, if somebody were to do this bring up board, we'll be more than happy. At ODSA, what we want to do is define the spec and collaborate with people. If somebody can implement this, would be great. Right. That's what NXP, we've been talking to NXP. NXP has offered some help in this direction. And but if we were identify a partner who can do all this, that'll be great. And ODSA wants to actually specify and collaborate with people, make sure, then demonstrate.
So Jayep, I suppose from the ADI side, you know, I don't know if we would be able to get any funding to help, but as a secondary option that I can offer is we can have our you know, power engineers or even, you know, to a level our system engineers help with helping with, you know, providing the power modules.
Oh, that'll be great, actually. So
yeah,
these are programmable power modules.
Yeah, and we could, you know, in theory, provide, you know, samples, you know, free of charge. So I could commit to helping on the power modules, especially, you know, we understand the power requirements for some of the FPGAs, especially for the Arctics. Obviously, just depending on the performance of the utilization of the FPGA, you know, the power levels will differ. But in the end, Jayep, I did post my email address on the chat if you want to reach out to me.
Okay,
you know,
thank you. Yeah. So
yeah, ultimately what we would need is just basically, you know, if you already have like a power tree defined, if you don't have a power tree, you know, just basically understanding the power levels, understanding the core voltages that you're talking about. I know you mentioned a few there. So I suppose we can offer that in terms of support. So if there's a third party that takes on the design and you want to connect us to that third party, you know, we could definitely work with them to help with that power levels or those power modules.
Okay, that'll be great. That'll be a great help, Eric, because we want this power modules to be digitally programmable, right? These voltages are not fixed because it varies at DOT, and any help you can offer in that to design programmable power supplies, high current, that'll be excellent.
Yeah, I mean, we have modules that go up to, you know, 150. You know, the switch load has to be low, so we're talking like 400 megahertz switching frequency, but I don't foresee it exceeding, you know, a higher frequency in terms of switching. But yeah, no, we have programmable modules that can provide up to 150 amps. So it just depends really on what the loads are and
Yeah, we
The
don't need
voltages.
probably that high. Probably 5 to 10 ampere range is.
Oh
you
yeah,
know,
those are
good.
just, point of lows almost, right? So those are easy. And we do have programmable ones where you can configure it. So we have like a option that you could do a controller based, and and then with the controllers you select the MOSFETs depending on the size, or depending on the current. Or we have a integrated system that allows, that it's almost like a fixed current output, but then it's configurable to up to 50 amps or 100 amps, depending on what the need is.
Sure,
Anyway,
we'll define that. Yeah.
Yeah, I'll stop blabbering about it. And, in the end, if you want us to help you in that arena, just, feel free to send me an email and then we can connect.
Absolutely. Thank you, Eric.
No
That
problem.
would be great. Yeah. So, Jawad, what do you think?
I have a couple more questions on the signal integrity analysis that you did for interoperability.
Yeah.
What was the maximum speed that you were able to get?
No, we only tried 16 gigabits. So run at 16 gigabits. We also have some studies done on 32 gig, but not for using this platform. But the dice themselves can only do 16 gig.
And for those 20 millimeter channels, you think everything is within the budget?
Yeah, within the budget. Yeah, we have an adequate budget.
Because that independently, both companies have tested interop of their own chip, right?
Correct. Both the D-Matrix and Blue Cheetah agree with that assessment. Yeah, I think Blue Cheetah did their own simulation as well.
Okay. Do you recall the minimum line space on the ATMS substrate that they're offering?
I believe it's 912, but we'll have to confirm what. But in this board we did 13 mils. 13 microns. 13.
13.
Yeah.
Okay. So, okay.
And that is within that ATNS capability.
Yeah. Do you have any sense of how will you take this platform to plug test if you were to ever do that?
So your question is, how will you use this platform for PlugFest?
Yes.
It's actually right now the package is being designed for Blue Cheetah and D-Matrix, right? So usually the PlugFest is any company can come and plug and test the interoperability, right? But in this, that's how it's done in the PCB world. But in the package world is a bit tricky because this is going to be need to be assembled on a substrate, and the pinout there is no standard for the pinout for this file. In fact, Blue Cheetah pinout is different from D-Matrix pinout, but we could actually kind of wire them up, the two. Right, but let's say this: if somebody were to actually show this wants to plug first and want to try their file, as long these pinouts are open because this package itself is open domain. Right, and if somebody were to design their file with one of these pinouts, they should be able to plug and play. Does that answer the question, Jawad?
So yes, in a way, but you're right that in the boards it's a lot easy to do PlugFest, and if you have to make a package to run PlugFest, this is very onerous.
Custom software for each combination, yeah.
Right. You have to think of a solution because this is gonna play the UCI, DOW no matter what.
So, sorry, Jawad, you sound a little far away. I'm having a hard time hearing you. Would you mind coming a little closer?
Oh yeah. So I'm saying that creating these interop packages to run PlugFest is a lot of overhead.
Correct.
The board here, I'm talking about for the industry, right? So
correct. Yes.
Come up with a solution to do PlugFest in a way that you take a chip, you plug it into the system, and on the other side you have the whole compliance report.
Yeah. Again,
right.
Basically,
yeah.
The pinout.
Have you thought about that, JP?
What is the question? Sorry, Jawad.
Make it easy for PlugFest for the industry and maybe create some standard for that based off of this work.
We can do actually. We haven't thought of that plug first point from direction. We are more thinking in terms of demonstrating interoperability, but something we can definitely define in this group, coming out with the kind of standard for the PHY. So what you're asking is that the standard pinout for the PHY, so everybody can follow that. Correct, but we don't have such a standard today, but something we can certainly discuss in this group.
Standard for the PHY test chip only. Each vendor could still have their own internal PHY pinout, of course, but just for the purposes of test chip.
Yeah, sure. Yeah. So, I mean, usually what the test chip, what they have is actually they put their PHY on the test chip along with their own circuitry, right? For the test circuitry. So it'll have some effect on the pinout of the PHY itself.
Okay, this is great, JP. I think I have all the information that I needed. So I appreciate receiving these slides.
Sure, Jawad. Yeah. So I think we actually defined some kind of timelines for based on a discussion. So the substrate fabrication, what ATNS was asking was about 16 weeks, and the substrate assembly 4 weeks, and on the duty, everything the NXP offered was about 8 weeks time at the time. It's like probably three months old data. Okay, so yeah, let us know, Jawad. I think we can stop here. If there are any questions that comes back, let us know, and then we can discuss this further. Okay, so anything, Shane or anybody else? Any questions?
I do have a general question.
Yeah, Paul, go ahead. Yeah.
How does ODSA manage the relationship with the chiplet suppliers, and do you coordinate with any other companies as part of these projects?
Sorry, say the question again.
So how do you manage the relationship with the chiplet suppliers like D-Matrix and Blue Cheetah? Do you have agreements with them to get their parts? Is this just a standalone project? Are they?
Yeah, so ODSA itself is not an organization that's capable of handling funds or a legal entity capable of doing an agreement, right? There's more, we view it as more a standards body where it allows the people to collaborate and work on a common projects.
Okay.
Right. So from that standpoint, we don't have any agreement, formal agreement, but since they actually adopted the spec that BOW developed, at the time they were actually committed to that, saying if you were to do this project, they will offer, they can provide the dies. Right. So this is probably like this project I've been working on for some time, probably 6 months, when we were kicking off this effort. But something we'll be more than happy to actually go and revisit this with these vendors and have actually kind of buy-in from them, like new buy-in from them. Yeah. So does that answer the question, Paul?
Yeah, that answers part of the question.
Yeah. Another thing I mentioned, the cost that is mentioned here, all this is not something ODSA will actually raise funds and then kind of distribute it to the vendors. It's not, ODSA is not set up for that, right? Instead, actually, we let the partners work directly and work out. That's how the previous POCs have been done. The Meta funded that the first POC directly with the partners. And ODSA was just actually managing the spec and the demonstration aspects of it, or technical aspects of it.
That explains it. Thank you.
Hey JP, this is Shane from Lux. I just have one question. There was a nice video on the OCP YouTube channel about the power integrity analysis of the package. And I was curious if there's like a similar one for signal integrity that's publicly available.
Yeah, so we haven't published any of those effort. We don't have it yet, actually. We have a lot of results, but we only that power integrity, that work you're talking about, came out of this package, right? This package took a lot of time to complete the power integrity. Signal integrity was much easier to close. The power integrity was actually kind of took some time, probably a couple of months of effort among different partners to close the design. And that work that you saw in the YouTube was actually came out of this work, this package development. So we actually probably in future will publish a signal integrity, but the signal integrity is relatively straightforward. And the reason we started publishing is power integrity is much more challenging, and we want to actually kind of share.
Got it. Okay. Appreciate that. Thank you.
Yeah, sure. Thanks for the question. Okay, so anything else before we close the call?
Thank you, JP. Super helpful.
Sure, Jawad. Yeah. So anyway, I think Boppy will be here next week. Right. So we can actually touch base with him as well. To this today he couldn't be here. He was in travel. So let's touch base further and see what can be done.
Sounds good.
Thank you.
Thank you.
Thank you,
Talk to you
JP.
then. Yeah. Bye.